Hello everyone, let's discuss about potassium dichromate, its preparation and its property. Formula of potassium dichromate is K2Cr2O7. It is a compound of chromium where chromium is present in +6 oxidation state and the group number of chromium is also 6. So this one is a frequently asked question in our CBSE exam. Give an example of a compound where the oxidation state and the group number are same. So in that case you can write dichromate ion. Color of potassium dichromate is orange in color. It is orangish in color and it is used as an primary standard in volumetric analysis. It is used in a leather industry and as an oxidant for the preparation of azo compound, which are the compound of nitrogen. It is used in the preparation of azo compound. Two oxo anions of chromium are namely chromate ion and a dichromate ion. Chromate and the other one is a dichromate ion. Formula of chromate ion is CrO4 2-. Here oxidation state and the group number of chromium is 6. Chromium, that one is surrounded by 4 oxygen here. So our tetrahedral structure will be formed. And its color is yellow. In case of dichromate ion, its formula is Cr2O7 2-. Here two tetrahedrons are sharing one corner, or you can say CrO-Cr linkage is there. And the color of potassium dichromate is orange. Two oxo anions of chromium are interconvertible. Chromate ion, which is yellow in color, changes to dichromate ion, which is orange in color. This step in the preparation of potassium dichromate, that one is a pH based step. If pH is less than 7, it means if you are providing acidic medium, then the yellow color changes into a orangish color because of the preparation or formation of dichromate ion. And if the pH is more than 7 in basic medium, it changes to yellowish in color. So the two forms are quite interconvertible. If you are providing acidic medium, then the chromate ion, it changes to the orangish dichromate ion. And if you are providing basic medium, then the resulting dichromate ion, which is orange in color, it changes to the yellow chromate ion. This one is the most important 2-marker question which usually come or asked from the preparation and properties of potassium dichromate ion. And the questions frequently asked here are: what is the effect of increasing pH on potassium dichromate solution? Or like, how can chromate and dichromate ions are interconverted? Or we can frame a question like, explain how color of potassium dichromate depends on the pH of a solution. Let's discuss how to prepare potassium dichromate from its ore. The ore of chromium which is used for the preparation of potassium dichromate, that one is a chromite ore. It is a mixed oxide of iron and chromium. Its formula is FeOCr2O3, or you can write it like FeCr2O4. Its color is dark green. This chromite ore, in presence of alkali and air, it changes to a chromate, which is yellow in color, and the chromate on acidification changes into dichromate. Chromite ore, it is FeCr2O4. Its color is dark green. It changes to chromate in the presence of alkali and air, which is CrO4 minus, and its color is yellow color. This chromate, it changes into a dichromate. Its formula is Cr2O72 minus, and its color is orange. On acidification, chromate changes into a dichromate. This part is helpful in word problems of which are based on the preparation of potassium dichromate. Chromite ore, FeCr2O4, in the presence of sodium or potassium carbonate and in excess of air, changes to sodium chromate, and the byproducts here are Fe2O3 and carbon dioxide. So in this reaction, 4 moles of chromite react with 8 moles of sodium carbonate and 7 moles of oxygen to produce 8 moles of sodium chromate and 2 moles of Fe2O3 and 8 moles of CO2. This chromate compound on acidification, Na2CrO4, on acidification by treating it with sulfuric acid, it changes to sodium dichromate, sodium ions and water. If you just simply check the reaction stoichiometry here, 2 moles of sodium chromate with 2 moles of hydrogen ion produces 2 moles of sodium ion. The compound formed sodium dichromate. Sodium salts are highly soluble in water, so that one is more soluble than K2Cr2O7, therefore not crystallize out. Crystals of sodium dichromate are not formed. So next step, what we do? We treat sodium dichromate with KCl and we get crystals of orange crystal of potassium dichromate, and byproduct here is NaCl. In this case, 1 mole of sodium dichromate react with 2 moles of KCl to give 1 mole of K2Cr2O7 and 2 moles of NaCl. As I already told you, potassium dichromate, it acts as a oxidizing agent. So a redox reaction takes place with potassium dichromate. If in a redox reaction, if one of the component get oxidized and the other one get reduced. So in this case, oxidizing agent is potassium dichromate, and the other component that behaves like a reducing agent. It means it undergo oxidation reaction, whereas potassium dichromate, it undergoes reduction reaction, decrease of charge in case of potassium dichromate. So dichromate, it changes into Cr3 plus in acidic medium. In dichromate, it is in 6. So from 6 to 3, decrease of oxidation number, a reduction takes place and it acts as an oxidizing agent. List of reducing agent here are like, suppose we react potassium dichromate with potassium iodide. So that produces iodide ion. Iodide ion changes to iodine. -1 to 0, increase of number. So oxidation, so it acts as a reducing agent. Stannous, SN2 plus, changes to stannic, SN4 plus. Like suppose I'm providing you SnCl2, so in presence of potassium dichromate, it changes to SnCl4. Next part, ferrous changes to ferric. Sulfide, H2S gas, hydrogen sulfide I am having here, it changes to sulfur in presence of potassium dichromate. Let's quickly discuss a type of questions frequently asked from the preparation and properties of potassium dichromate. One question I earlier told you, okay, give an example of an oxo anion in which the oxidation state and the group number are same. So in that case, you write chromate or a dichromate. Then a word problem, a 3-marker question, like an compound A, which is green chromium compound, green colored chromium compound, get fused in presence of alkali and oxygen, changes to a yellow color compound B, which on acidification changes to a orange colored compound C, and this orange colored compound C with KCl gives another orange colored compound, another orange colored compound, and this orange colored compound on treatment with Ki produces violet vapors of iodine. Identify A, B, C, D. So in this case, chromium compound, green color. Let's make a help box here. Chromite, FeCr2O4 is green. Chromate, whether that one is a sodium chromate or potassium chromate, that one is yellow in color. Dichromate, whether sodium dichromate or potassium dichromate, the resulting color is orange. So a green color compound, chromium compound, that one is a chromite. Then it changes to yellow colored compound on fusion with alkali and in presence of air. That yellow colored compound is a chromate. This yellow colored compound on acidification, it changes to a orange colored compound dichromate, which is a sodium dichromate. Basically, a orange colored solution is obtained because sodium salts are more soluble in. Then this orange colored compound with KCl, it changes to crystallize out potassium dichromate. Then the resulting potassium dichromate, which is a powerful oxidizing agent in acidic medium, it changes iodide into iodine. So by this way, you can do or simplify your word problem. Let's frame one more word problem, because a word problem question, that one comes under a 3-marker question. And mixed oxide of iron and chromium A in presence of alkali and oxygen air, it changes to a yellow colored compound B. This yellow colored compound on acidification, it changes to a orange colored compound C, and this orange colored compound with KCl produces another orange colored compound D, which is a strong oxidizing agent, and this D on reaction with H2S produces yellow sulfur, yellow colored sulfur. So in this case, mixed oxide of iron and chromium, that one is obvious. Chromite ore, so it is FeCr2O4 here. The answer is FeCr2O4. Changes to a yellow colored compound in presence of air and alkali. So when it gets fused in presence of air and alkali, it gives a yellow colored compound which is a sodium chromate. This yellow colored compound on acidification, it produces orange colored compound which is sodium dichromate. And this sodium dichromate with KCl gives a another orange compound which is a strong oxidizing agent. It is potassium dichromate. Hopefully you are able to understand how to do word problem based on the preparation of potassium dichromate. Another category of question asked from this part are the fill-ups type of, like suppose CrO4 2 minus H plus. This part is given to you. Or we can frame like Cr2O7 2 minus dichromate with Cl minus. Or we frame like a question Cr2O7 2 minus with Fe2 plus. One more we can frame Cr2O7 2 minus plus sulfide. So let's start. In first case, chromate in acidic medium, it changes to a dichromate, orange. Then next, dichromate with chloride, dichromate ion with chloride in acidic medium, it changes, dichromate, it changes to Cr3 plus, and chloride, it changes to Cl2. Because dichromate, that one behaves like an oxidizing agent, and chloride, that one behaves like a reducing agent here. Next part, Cr2O7 with ferrous, again dichromate, it behaves like an oxidizing agent, it changes to Cr3 plus and ferrous to ferric. In last, we are having dichromate ion with sulfide. So dichromate, that one changes into chromium and sulfide to sulfur. This one is a basic skeleton equation. You can easily balance the number of atoms and the charge on both sides of a reaction.